Put the glasses on. All right, this is the second part of the kinematics, and today we're going to look at one-dimensional motion, constant acceleration equations. So as you already know, acceleration is defined as the change in velocity per unit time and can be found by using, again, in your physics notes, the equation came up, but on my Google Doc, it is missing. So A is equal to delta V over T, which is A is equal to VF minus VI over T. And like I always recommend, take out your Regents physics reference tables and have them as we're going along because we can add notes to both. So when you manipulate the formula and solve for VF, you end up getting VF is equal to VI plus AT. Again, it will always happen that if you list your givens and unknowns, you will be able to pick the proper equation. Like I showed you in class, we can also derive other equations, but you really only need to know two and everything else can be figured out. All right, so as we've done in class, I've shown you both derivations. And again, at any time, if you need to see them again, you can. But on your reference table, they have the final equations. So D is equal to VIT plus 1/2 AT squared, and VF squared is equal to VI squared plus 2AD. All right, so again, both of these equations are derived from the acceleration equation. A is VF minus VI over T, and D is equal to VT. Now, my advice at this point is add them to these notes, even though they're in your notebook. So A is VF minus VI over T. Right next to that, write D is equal to VT, and then the average velocity is VF plus VI over 2. So when you find the displacement, it's equal to VF plus VI over 2, in parentheses, times T. And again, you have these in your notes from class. You should also have them on your reference table at this point. Again, when you're solving physics at the Regents level, you have all the equations. It's a matter of listing the givens and unknowns, writing down the equation and solving. It's the same exact procedure. The only thing we want to look at now is if an object starts or stops at rest, VI or VF will be equal to 0. So like we've written on the reference table, you always want to ask yourself the question, is VI or VF equal to 0? Because that will give you a piece of information that you need. So in this one, Rob starts from rest. So immediately over the rest, and it's starting, you're going to write VI is equal to 0, right in the problem before you even get to the givens and unknowns. They give you the acceleration and they give you the time, and they ask you how far do you go. So notice you know 3 out of 4 of the items. You look above at the equations, you substitute and solve. Again, like we've done previously, I will upload these in the Edpuzzle. You'll see the video, and then your final solution you will then put in the Edpuzzle. So again, use the notes, write what you need, and then we'll go back and reinforce it in an Edpuzzle. Okay, next one. A bowling ball is moving with 20 meters per second from rest. So in this case, it's coming to rest. Now notice in this case, both of these questions, you're moving forward. So the direction will obviously be positive. You're just considering this case positive or negative acceleration. So in most cases, they're looking at the magnitude of the acceleration. That means how big it is. So the word acceleration could be a vector, could be a scalar. If you know it's still straight line motion, positive and negative would be the two directions. Eventually, when we go east or west, then those would be the directions also. All right, so with the bowling ball, in this case, you have the VI, you have the VF, and you have the D. So again, you're going to pick the final equation that works for that. Notice these are all just positive or negative for the speeding up or slowing down. Okay, the next one, we're going to kick a soccer ball. So again, from rest means VI is 0. You have D and you have T. So the same procedure. All of these examples are using the 3 equations above. Number 4, initially moving at, so there's your VI. You accelerate, and the question is how fast will it be moving? So you're looking for the final velocity, and they give you D. Again, at first, they'll be very confusing. Again, I will show you other charts to help you solve these, but basically there's four givens and unknowns. You'll know three of them, and you're going to solve for the fourth. And then the last one will be Superman is flying at 300 meters per second. He then accelerates at a rate of 20 meters per second squared for 10 seconds. How fast is he flying now? Again, you're looking for his final velocity. And again, everything is in a straight line. So the answers in this case will be positive. We'll show you the direction. Again, right now we're looking more at the magnitude. We'll look at varying directions in a little bit. Okay, so I hope that helps you a little bit. Again, to recap, givens and unknowns, you'll know 3 out of 4, and then you'll solve for the fourth variable. Again, with this repetition, 80% of all physics problems will be solved this way. So vector and scalar addition is one way, the equations will be the other, and almost any question you're given on your Regents exam can be solved. The next level will be, all right, what does this actually mean? And that will bring us into forces. What creates this motion and how does it occur? All right, have a great day. Thank you.